Now we're going to look at the code for the car park slots. First, we're importing the threading to make a multiple threads which working parallel to each other. We are importing RPI to GPIO as GPIO, importing the time library, import numbers display. This number display is for the 7-segment display which showing the numbers of the available car park slots. Import rasp_I2C_photon. That is the library that I'm using for like sending a data from Raspberry Pi to Particle Photon. Then we get the set. We're going to do a set warnings as false, and we set the mode for the GPIO as PCM. As we discussed before, PCM and board is a different kind of name for the GPIO on Raspberry Pi. We declaring 5 variables for the different car park slots. The slot 1 is connected with GPIO number 6. Slot 2 is connected with GPIO number 20. Slot 3 is connected with number 16. Slot 4 is connected with GPIO 12. And slot 5 is connected with GPIO 21. The LEDs in above each car slot also connected to different GPIO. So slot 1 green is connected to GPIO number 9, and slot 1 red is connected with GPIO number 11, etc. till GPIO number 18 for the red LED for slot number 5. We're declaring variable called slot 1 state as 0, slot 2 state as 0. That is the state of each car park slots. We start with 0, as if there is no park car in these slots. And we declare a variable for slots as 5 and parked cars are 0. We set up all the GPIO for slots that's connected with avoidance, obstacle avoidance sensors as GPIO in, with pull up down as GPIO dot pull up down up. And then we set up the LEDs, all the LEDs as GPIO out, either red or green for the different slots. We're declaring a function called parked car calculation. That is for calculating how many cars are parked in the car park. We're declaring each slot state as global, and we calculate the parked car as adding the 5 car slots. This gives us a parked cars, and we can print the parked cars. The next function is update displays numbers. So we have slots variable and we have parked variable. We minus the slots minus parked car to get the available cars, and then we call the function is show available in the numbers display library. The next function is slot 1. So we have a slot 1 state variable as global, and then we're making a loop. So if the slot number 1 is giving us an input of 0 and slot 1 state is equal to 0, what does it mean? It means like the obstacle avoidance has getting a car in front of it. So we're going to and it was the state of this slot was 0 before. So we're going to change the slot state to 1, which means like there is a car there, and then we going to calculate the numbers of the car park to update the number of parked cars, and we're going to update the display number, which showing on the 7-segment display, and we're going to change which LED is working above it. So we're going to give slot 1 green to be low, so turning off the green LED, and we turning the red LED is on. And we sleep for 1 second and we print park 1 is occupied now. Vice versa, if slot 1 is showing, if giving input of 1 and slot 1 state was 1, what does it mean? It means like the car has left the car park, so the obstacle avoidance sensor is not sensing it anymore. And the slot 1 state it was 1, we change the slot state to 0, and we calculate the parked car by calling the function of parked cars calculation, update the display number, and then we switch back again the between the green and LED. So we put the green LED above the car slot to high, so turning it on, and putting the slot 1 red, the red LED above it, to low, and sleep for 1 second and print park 1 is empty. We're doing exactly the same of this function with each car park slot, as you can see, exactly the same. So if any sensor, like obstacle avoidance sensor, has getting an input of 0, this means like a car has been parked and the slot state was 0. We change the slot state to 1, which means like it now occupied, and then we calculate how many cars are parked and update the display number, and we switch the LEDs above the car slot between green to be turned off and red to turn on, and then sleep for 1 second and print this car slot is occupied. And the other way around, if the slot was having a car before and now we're getting input of 1, which means the car has left already, and the slot state was 1 before, we're changing the slot state to 0. We calculate the car which is parked, update the display number, and change the green to be high, which putting the green to be on, and we change the red to low, which turning it off, and sleep for 1 second. The next part is sending the data. So we're getting all the 5 slot variables and we're making a loop. We're putting the slot state into array or a list, and data.append. So we append each slot state to this list. So slot 1, slot 2, slot 3, slot 4, slot 5. And then we send this all data through the library of rasp underscore I2C underscore photon dot write data. And we're going to look at this in different video. That is all about the car park slots code.